Welcome students. Today we are going to solve this problem. That is, given problem is y double dash equals y plus x y dash with the initial conditions y of 0 equals 1 and y dash of 0 equals 0. This problem we have to solve. That means we have to find the value of y when x equals 0.1. Now this type of problems can be solved by Taylor's series method. Taylor series method we can solve. The Taylor series is this: yn plus 1 equals yn plus x minus x naught to the power 1 divided by factorial 1 into first derivative n plus x minus x naught to the power square divided by 2 factorial y n, then double derivative plus x minus x naught cube divided by 3 factorial y third derivative at x equals x n plus dot dot dot. Now in this equation you put n equals 0. When n equals 0, this equation will become like this equation. When n equals 0, what we are getting is that here n equals 0, therefore yn, so y1 x equals, here n equals 0, you will get y0 plus, here n is equal to 0, therefore all this will come as it is. Here n becomes 0 and first derivative we have to find out plus, and this you write as it is. Here n becomes 0 and this is as it is. Here second derivative at x equals 0 plus come here, and here also all things will come as it is, and here n becomes 0 here, and we have to find the third derivative at x equals 0 plus dot dot dot. So this equation will become this equation when n equals 0. When n equals 0, this equation becomes like this equation. Now we'll take one problem. This is the problem given to us. That is, given ordinary differential equation is y double dash equals y plus x y dash with the initial condition y of 0 equals 1 and y dash of 0 equals 0. So these all are given to us. What we need to understand is that what is the value of y when x equals this. That's what we have to find out here. All these are given, initial conditions given, and ordinary differential equations also given here, and our aim is that we have to find the value of y when x equals 0. That's what our job here. Now Taylor's formula is very helpful for us to find the value of y when x equals 0. Taylor's formula we have to remember. Just now we formulated the Taylor's formula. This is the Taylor's formula. Okay, y1 of x equals y0 plus x minus x naught to the power 1 divided by factorial 1 to first derivative of y at the particular point 0 plus x minus x naught square divided by 2 factorial the second derivative at x equals 0 plus here x minus x naught to the power 3 divided by 3 factorial into the third derivative of y when x equals 0 plus dot dot dot. This already we know that is called Taylor's series. So that is what this one. So we have to find what is y naught, what is x naught, what is y dash at x equals 0. Here also x naught. We have to find what is second derivative of y when x equals 0. Here we have to find what is the third derivative of y when x equals 0. So these components, that is y naught, x naught, y dash naught, y double dash at x equals 0, y triple dash at x equals 0. If we know all of them, then you substitute in this equation, then we will get what is y of x or y1 of x. In this function, put x is equal to 0.1 in this equation. Put x is equal to 0.1, then we will get Taylor's series. At the particular point, we will get the value of y. So y of x will give you Taylor series. When x what asked, you substitute, you will get the value of y at the particular point. That's what the question to us. Now let us find the components. We have to find the components, means y naught we have to find out, x naught we have to find out. Then first derivative of y at x equals 0, that we have to find. Then here the value of second derivative at the particular point x equals 0. Here the third derivative of y at the particular point x. All these things we have to find out. Now let us find one by one. So what is given to us from the initial condition here? Y of 0 equals 1, okay, and y dash of 0 equals 0. That's what we are taking here. Y of 0 equals 1. What is the meaning? Here x value, am I correct? So when x naught equals 0, when the initial value of x equals 0, the value of y is 1. When x naught equals 0, that is this place equals 0, the value of y equals 1. So that's what I have written here. When x naught equals 0, y naught equals 1. When the initial value of x equals 0, the initial value of y equals 1. Now come to the second initial condition here. Y dash equals 0, that is first derivative of y equals 0 when x equals 0. That's what I have written here. First derivative of y equals 1. First derivative of y equals 1 when x naught equals 1. When x naught equals 1, its first derivative is equals 1. That's what the meaning here. So how I can write when x naught equals 0, 0, y naught of dash, that is the value of x equal to 0, the value of y naught of the first derivative equals 0. So from the given two boundary conditions, we can get the value of x naught, y naught, and then x naught, and then y naught first derivative at y naught. So all these things we can find out. Okay, x naught we can find out from this, that is equal to 0. So this x naught equal to 0 we can substitute here. So x naught we have found out. X naught we have found out. So x naught equals 0, that we can substitute here. The x naught equals 0 we can substitute here, and x naught equals 0 we can substitute here. So from the given condition we can get x naught, and that we can substitute here. Then y naught equals 1. So y naught equals 1. Look at this Taylor formula. Here y naught comes. So this y naught value we can substitute here. Y naught value we can substitute here, because we have got the value of y naught. Y naught equals 1. That we can substitute here. And then we have here y naught dash, that is first derivative of y when x naught equals 0. Okay, or the initial value of first derivative equals 0, that we can substitute. So in this equation, where is that? Look at that. Yes, here. So this particular value y naught dash, that is first derivative of y at x equals 0, we can substitute here. Okay, so now remaining what we need to is that we have to find this second derivative at x equals 0, third derivative at x naught equals 0, third derivative at x naught equals 0. So if we find out this and this, that's all our duty. Just we substitute all those values in this equation, we will get the Taylor's formula. So in that Taylor's formula, substitute 0.1 here, and we simplify, you will get the value of y of x when x equals 0.1. Now look at that. How can we find out this? That is second derivative at x naught equals 0, third derivative at x naught equals 0. Okay, so that's what we have to find out here. Now look at that. From the given ordinary differential equation, what is given to us is this, y double dash equals y plus x y dash. What is the meaning here? The double derivative or second derivative of y with respect to x equals y plus x into the first derivative of y with respect to x. That's what the meaning here. So that's what is given to us. Now what is the value of the second derivative of y with respect to x naught? When x naught equals 0, what is the value of the second derivative of y? So in the place of x naught we have to put 0. Okay, so that's what is done here. So y naught means the value of second derivative of y when x naught equals 0. Similarly here you take this y here, and then here I am taking the value of y at x equals 0. That's what I am taking. So that's what I have here, the value of y when x equals 0, when the initial value is 0, x equals 0 plus. Now look at that. This is x given. So what is the value of x when the initial value is given, x naught, and that's what I have written here. Now similarly here y dash, general case, but I am interested in when x naught equals 0, what is the first derivative of y? That's what I have written here. When x naught equals 0, what is the first derivative value? That's what I am interested in. So this equals y naught. Already we have the value is y naught equals 1. Y naught equals 1, that we are substituting here. here we are substituting y naught equals 1, you substitute here 1, x naught equals 0, see given here, x naught value is given here 0, and the value of first derivative of y at x equals 0, first derivative of y at x equals 0. Now look at that, first derivative of y at x equals 0 is equal to 0. Am I correct? So y at first derivative at x equals 0, that value we are substituting here. So this value we are substituting here, that means we are substituting here. So what we are getting is 1 plus 0 into 0, 0. I will get 1. Okay, 1. This is equation number 2 I am taking. Okay, the given equation I am taking as it is. Then when x equals 0, that is when the initial value x naught equals 0, what would be the value of this particular given equation? That is I am finding out. So why I am finding out this value, I have to substitute here. That is why I am finding out this. Now I have got the value of y naught, that is the second derivative of y when x equals x naught, it becomes 1. Am I correct? So after knowing the second derivative of y at x equals x naught, I can substitute the value 1 here. Okay, I can substitute that value 1 here. So now the remaining thing we have to understand is this, we have to get is this. Am I correct? So the third derivative of y at the particular point x equals 0, when initial value of x equals 0, what is the third derivative initial value? That's what we are interested. That we'll find out now. Now already we know that y double dash equals y plus x y dash. The meaning is that the second derivative of y with respect to x equals y of x plus x into first derivative with respect to x. Now from this it is possible to find the third derivative of y. Third derivative of y we can find out. Am I correct? So second derivative of y with respect to x is y plus x plus y dash. Now differentiate this one more time, you will get third derivative. Am I correct? Differentiate this function one more time with respect to x, y one more time with respect to x, you will get this. Now we know from the differential equation that if we differentiate this, we have to differentiate this side also. So if you differentiate this with respect to x, this y will become y dash, dy by dx will come that equals y dash, plus here d by dx of xy dash, d by dx of xy dash, that this is uv method we have to follow here. D by dx of x into y dash, d by dx of x into y dash. That means we have to use the formula d by dx of uv. That means what? First we have to differentiate this, we have to keep this as a constant, plus second we have to differentiate this, keeping this as a constant. That is differentiation formula. Okay, whether you understand that the differentiation formula or not, I don't know. So what I am doing is that, can I write here about that particular formula? D uv sorry, it is not clear to you, I think. I will strike out, and that particular formula we know well. that particular formula is that d uv equals u dv plus v du. Am I correct? So this is the formula. First we have to differentiate any one function, keep it a constant, differentiate this, plus then keep this as a constant, differentiate this with respect to x. That's what the formula. Am I correct? So that idea I am using here in these two functions. Okay, so when I use this particular idea here, what I will get is that it's not working. That's a problem. Okay, d by dx of x y dash. First I am keeping this as a constant. This as a constant I am keeping here, and then I am differentiating this. When I differentiate this, I will get this y double dash. Already one dash is there, one differentiation is there. Now one more differentiation I have to do. So double differentiation plus. Now I am keeping this as a constant, this as a variable. So I am differentiating this with respect to x, and this as a constant. I will get the last term. Okay, I repeat again. Now the third derivative equals, already y is there, so one more y will come there, and therefore you will get y dash plus. Here d by dx of uv method, first keep one constant, this, differentiate that, you will get x y double dash plus. Secondly, we are keeping this as a constant and this we are differentiating, we will get dx by dx is 1 and y dash is here. So the third derivative of x, the third derivative of y with respect to x equals y dash plus xy double dash plus y dash. That is what we will have. Now again I want the third derivative of y at x equals 0. Third derivative of y at x equals 0. That means y not triple dash, I mean third derivative at x equals 0. That notation is that y triple dash 0. That's what I have here. Okay, similarly I need the first derivative of y at x equals 0. First derivative of y at x equals 0, that is what, this one, plus the value of x at 0. That is what, value of x at 0. Here the double derivative of y at x equals 0 at initial point, y double dash at x equals 0. That's what here you should have. Oh, I am sorry, here it is left out, so we must have a 0 here, we must have 0 here. That means the value of double dash at x equals 0, value of double dash at x equals 0, value of double dash at x equals 0. Now come to the last term here, the first derivative of y, when x equals 0, the first derivative of y when x equals 0. Okay, so all this equation or this equation at x equals 0, we will get this. Now for y dash of 0 we have the value already. See, look at this, y first derivative equals 0, the value is 0, so that we are substituting here, we will get this. X when initial value of x naught. The initial value of x naught is 0. That's what we have here. And then y naught double dash value is 1, but here 0 into 1 will come here, therefore we'll get 0 here, plus last one, the value of first derivative. Where is that? Value of first derivative when x equals 0. Value of first derivative at x equals 0 is 0. That value we have put here. So if you add all these 0, you will get the value as 0 here. Okay, and so we have got the value of y. Value of y means the third derivative of y with respect to x equals 0 is 0. Third derivative of y with respect to x equals 0 will be equal to 0. That's what we are needed here. Am I correct? Third derivative of y when x equals 0. Third derivative of y when x equals 0. Third derivative of y when x equals 0. So we have got all the components here. Y naught we have 1. X naught we have the value 0. The y first derivative, y of first derivative at 0. Where is that? Yes, here. The value of y dash at x equals 0 is 0. So that also we have. Then we have the given equation. From the given equation we are substituting the initial condition. We will get y double dash of 0 equals 1. So here y double dash of 0 equals 1. Lastly we have y triple dash of 0 equals 0. Okay, so we had all these things. So we are substituting the second equation and the third equation in equation number 1. What we are getting is this. Now look at that. All these values substitute. All the values y naught, x naught, y dash naught, y double dash naught, y triple dash naught. Substitute all these values we have got here, and if you substitute that in this equation, what we are getting is this. y1 of x equals y naught. Y naught value is what? 1. That we have, plus here x naught is equal to 0, here also x naught is equal to 0, here also x naught is equal to 0. So if x naught is equal to 0, x power 1 divided by 1 factorial, y naught to the power 1 is 0. Therefore we have here x power 1 divided by 1 factorial into 0, because y naught of 1, look at that, y naught of first derivative equals 0. That we are substituting here, plus come this particular term, y naught is equal to 0, x square divided by factorial 2, and what is y naught double dash? Y naught double dash is equal to 1. So that 1 we are writing here. Come to the last term here, x minus x naught, this is equal to 0, x cube divided by 3 factorial, and then here the value of the third factorial at x equals 0. The value of third factorial at x equals 0 is 0, and that value we are putting here. So as a result, this value will be striked out, this value will be striked out. Now look at that. You will have 1 plus x squared by 2, right? 1 plus, this is striked out, this and this, because of 0 value here, we will have 1 plus x squared by 2 factorial. 2 factorial means 2, 1 into 2. So y of x equals 1 plus x squared by 2. So what is this? It's called Taylor series for the given problem. For given problem, this is the Taylor series. Okay, but what is the question here is that we have to find the value of y when x takes a value 0.1. when x takes the value 0.1, what is the value of y? That is what we are interested. So in this equation, put x equals 0.1. That is, when x equals 0.1, what is the value of y? So substitute in this particular place 0.1, y equals 1 plus 0.1. So here it is not 0.2. You must change that. It's not 0.2, it is 0.1. Right. So when x equals 0.1, we will get, when x equals 0.1, it will be equal to 1 plus x squared divided by 2. So here x equals 0.1, therefore 1 plus 0.1, it is squared divided by 2. Okay, it's squared divided by 2 equals 1.0050. You check if you have doubt. Okay, 0.1 into 0.1, square it. Okay, so from the calculator I am calculating that and seeing whether it is correct or not. Now I am going to the calculator now. Yes, 1.1 into 0.1 equals 0.01 divided by 2. Divide by 2, I am getting 0.05. Then with this I have to add 1. So plus 1 equal to 1.005. 1.005. That is what the answer I am getting for this problem. Okay, this is the answer I am getting for the given problem. Okay, so quick recap of what we have done. We must remember the Taylor series formula. It is better to recall this yellow color formula there, and this one, y1 of x equals y0 plus x minus x0 to the power 1 divided by 1 factorial. First derivative of y at x equals 0 plus x minus x0 square divided by 2 factorial into y. Second derivative at x equals 0 plus x minus x0 to the power 3 divided by factorial 3 y. Third derivative at x equals 0. So we need to recall this formula, and then from the given problem, initial condition will be given. For the initial condition, from the initial condition we get what is x0 y0. So x0 y0 we can find out. Then here we need the second derivative at y0. So for that we are taking the given equation. From the given equation we can get the second derivative value at x0, that we can substitute here. To get the third derivative, what the given ordinary differential equation, you differentiate one more time, you will get the third derivative at x0. That's what we have here, the value is 0. So all components we got here, x0 y0 first derivative, y0 second derivative, and third derivative at x0 equals 0. Just substituting all these equations in the very famous Taylor's equations that we have already know from the equation number 1, you will get the equation in x, in powers of x. Okay, that is called what we say, Taylor's series we say. In the Taylor series, what is in the problem they are asked to find out. here what is y value when x equals 0.1, that's what they are asking. From the Taylor series, that is this equation, substitute x value, we will get the corresponding y value for the given problem. Okay, so actually what we do here is that for this second degree, this is second degree equation, second order differential equation, we can make the corresponding y of x. From that y of x we are substituting the value and we will get the corresponding y value. This is what we are doing. Thank you very much for the past 35 minutes you have been with me, and you repeatedly go through this particular problem again, then only you will understand. And here the given problem is this, y double dash equals y plus xy dash. So this is the Taylor series problem for the second order or higher order, we can say. And the problem may vary, but the methods are same. So from the given book, lot of problems are done. You go through that particular problem, all the problem will be followed this pattern, and you will get the corresponding answer. Okay, so with that I have to come to the end of this session. All the best for your examination. Thank you.